Welcome to Hello World Academy, where we unlock the doors to technology, coding, and data. Whether you're just starting your journey in tech or looking to level up your skills, you've come to the right place. I'm thrilled to have you join us today. In this special episode, we're diving deep into the world of databases with 80 SQL interview questions and answers that you absolutely need to know. Whether you're preparing for your next job interview or just looking to refresh your database knowledge, we've got you covered. Let's kick things off with the basics and gradually move to more complex concepts. Ready? Let's jump in. What is SQL? SQL stands for Structured Query Language. It's the standard language for dealing with databases. With SQL, you can create, read, update, and delete records in a database. It's essential for querying data, updating records, and managing database schemas. Whether you're a database administrator or a developer, SQL is a fundamental skill you need to master. Moving on to question 2. What is a database? A database is essentially a structured collection of data, usually stored electronically. It's managed using a database management system, or DBMS for short. Databases play a crucial role in managing large quantities of data efficiently and are widely used in various applications, from powering websites to running banking systems. Understanding databases is key to managing and interpreting data effectively. Question 3. What do you mean by table and field in SQL? In SQL, a table is where your data lives, organized in rows and columns. Think of it like a spreadsheet where each row represents a unique data record, and each column, known as a field, represents a type of data that column stores. Fields have specific data types, like integers, strings, or dates, determining the kind of data they can hold. Understanding tables and fields is foundational to working with databases, as it's how you structure and store your data. Moving on, question 4. What are the different types of SQL commands, and what are their purposes? SQL commands are categorized into 4 main types. First, we have DDL, data definition language commands, such as create, alter, drop, and truncate. These are used for defining and modifying database structures. Next, DML, data manipulation language commands like select, insert, update, and delete are crucial for data retrieval and manipulation. Then there's DCL, data control language commands, including grant and revoke, which are used for data access control. Lastly, TCL, transaction control language commands like commit and rollback, are essential for managing database transactions. Moving on to our next point of discussion. What are the key features of SQL? The key features of SQL include its ability to execute queries, retrieve and manipulate data through DML, define and modify data structures via DDL, control access to the database with DCL, and manage transactions using TCL. SQL is renowned for its robust querying capabilities, data integrity enforcement, support for joins and views, and portability across various database systems. Understanding the differences between SQL and NoSQL databases. SQL databases, or relational databases, are structured in tables and use SQL structured query language for defining and manipulating data. They're ideal for complex queries and ensure ACID compliance for reliable transactions. Examples include financial systems and enterprise applications. Contrastingly, NoSQL databases are non-relational, supporting a variety of data models like document, key value, wide column, and graph databases. They prioritize scalability, flexibility, and fast read-write operations, making them perfect for large-scale, real-time applications, including big data analytics and IoT solutions. Key differences at a glance. SQL databases scale vertically, requiring more powerful hardware for expansion, while NoSQL databases scale horizontally, spreading out across more servers. SQL is known for its fixed schema, complex queries, and transaction management with ACID properties. NoSQL offers dynamic schemas, tailored query languages, and a more relaxed approach to data consistency. And there you have it, a concise comparison of SQL and NoSQL databases. The right choice depends on your project's needs, structure and reliability from SQL, or flexibility and scalability. Question 7. Describe the structure of a typical SQL database. Answer. A typical SQL database is organized into tables, which are made up of rows and columns. Each row or record holds unique information, while each column or field represents a specific type of data. These tables are not just random collections. They're defined with precise data types, constraints to ensure data integrity, and relationships to connect tables together. Primary keys within a table identify unique records, and foreign keys link records between tables, enabling efficient data retrieval and manipulation. Question 8. Does SQL support programming language features? Answer. While SQL is primarily a query language, it does incorporate elements reminiscent of programming, such as conditional statements, loops, and functions within its syntax. These programming-like features enhance SQL's capability for dynamic and complex data handling. Moreover, SQL's versatility is evident in its integration capabilities with other programming languages, facilitated by various libraries and APIs. Question 9. What is the difference between SQL and PLSQL? When we talk about SQL, we refer to it as the standard language for querying and manipulating databases. It's primarily used for data retrieval, updates, insertion, and deletion. Its strength lies in straightforward data manipulation and query operations within a database. SQL is direct in its approach, executing queries and operations on the database for a range of tasks from basic to complex. On the flip side, PLSQL is a procedural language extension for SQL, crafted by the database giant Oracle. PLSQL takes SQL a step further by introducing programming constructs, such as variables, loops, and conditions. This makes it especially suitable for writing more complex database applications that require advanced data operations and logic. PLSQL's prowess allows the bundling of SQL statements within procedural logic, significantly enhancing the efficiency and power of database operations. It is the go-to for creating sophisticated server-side procedures, functions, and triggers, thereby boosting database functionality and control. In essence, while SQL sets the foundation for interacting with databases, PLSQL builds on that foundation to provide a more advanced and powerful toolset for database management. Let's dive into some key SQL concepts that are fundamental to database structure and integrity. Understanding these will help you design more efficient and reliable databases. Question 10. Could you explain the different types of keys in SQL? Answer. In SQL, keys are essential for identifying and linking tables, as well as preserving data integrity. Let's go over the main types of keys. Primary key. This is a column or a group of columns that uniquely identifies each row in a table. It must hold unique values and cannot contain nulls. Foreign key. A foreign key is a column or group of columns that creates a link between data in two tables. It points to a primary key in another table and maintains referential integrity. Unique key. This constraint ensures that all values in a column are different. Unlike a primary key, it can have null values, but it cannot have duplicate values. Composite key. A composite key, which is a primary key made up of two or more columns, is used when no single column can uniquely identify a row. Candidate key. These are columns in a table that could serve as a unique identifier for rows. The primary key is chosen from these candidate keys. Alternate key. An alternate key is a candidate key, not selected as the primary key. It can uniquely identify records, but isn't the primary identifier. Super key. A super key is any combination of columns that can uniquely identify a row. A primary key is a specific type of super key that is the most minimal. No subset of its columns can be a super key. Now, let's focus on the primary key specifically. Question 11. Can you explain what a primary key is in SQL? Answer. A primary key is the main unique identifier for each record in an SQL table. It ensures each record is unique and can be identified distinctly, upholding the table's data integrity. This key must contain unique values and cannot be null. Question 12. Explain the difference between a primary key and a unique key in SQL. In SQL, both primary keys and unique keys are integral to ensuring the uniqueness of data, yet they serve different purposes and have distinct rules. Primary key. Uniqueness. It ensures every value is unique across the table, disallowing duplicates. Null values. Nulls are not permitted. Every record must have a non-null primary key value. Purpose. Its main role is to uniquely identify each record in the table. Constraints. A table can have only one primary key, and it can be composed of either a single column or a combination of multiple columns for a composite key. Unique key. Uniqueness. Like a primary key, it ensures the uniqueness of values in its column, but is used for columns other than the primary key. Null values. It can contain nulls, with the limitation of allowing only a single null for each unique constraint. Purpose. To prevent duplicate values in a column that is not the primary identifier. Constraints. Unlike primary keys, a table can have several unique keys. These keys play a pivotal role in database design, with the primary key acting as the main identifier for table records and the unique key ensuring additional columns have distinct values. Question 13. What is a foreign key? Answer. A foreign key is a column or group of columns that creates a relationship between two tables. It's a reference in one table to the primary key of another table, enforcing a valid link between the data in both tables and ensuring referential integrity. Question 14. What does a foreign key represent in a database? Answer. In a database, a foreign key represents a link or relationship between two tables. It identifies one or more columns in a table that correspond to a column or columns in another table. This key is crucial for maintaining data consistency and integrity across related tables. Question 15. What is a constraint in the context of SQL? Answer. A constraint in SQL is a rule applied to table columns to limit the type of data they can hold. This ensures the accuracy and reliability of the data. The common types of constraints include primary key constraint. Uniquely identifies each table row. Foreign key constraint. Links tables and enforces referential integrity. Unique constraint. Ensures all column values are unique. Check constraint. Requires column values to meet a specified condition. Default constraint. Sets a default value for a column if no value is provided. Not null constraint. Guarantees a column cannot have a null value. These constraints are fundamental for maintaining data integrity, consistency, and compliance with the defined business rules of the database. Question 16. What is the default constraint in SQL? Answer. In SQL, the default constraint is a type of rule that you can apply to a column to automatically assign a preset value to it in case no other value is provided when a new record is created. It's a fail-safe mechanism to avoid null values in columns where having meaningful data is critical. Imagine you have a column for date created. You could use the default constraint to ensure that every new record automatically receives the current date, ensuring data consistency and integrity without manual input. Question 17. Can you explain the where clause in SQL? Answer. The where clause in SQL is a powerful tool for filtering and refining data retrieval. It allows you to specify conditions that the data must meet to be selected. For instance, if you run a query like select from employees where department equals marketing, SQL will scrutinize each record and only return those where the department column matches marketing. It's like asking a very specific question to your database and getting a precise answer. Question 18. What is the order by statement in SQL? Answer. The order by statement is what you'd use when you need your SQL query results organized in a specific order. This could be alphabetically, numerically, chronologically, and so on, either ascending from the lowest to highest with ask or descending from highest to lowest with desc. So if you want to see your employee records sorted by name, you would use select from employees order by employee name ask. And like magic, SQL presents your data in a neatly ordered list. Question 19. Could you explain the and or statements in SQL with an example? Answer: certainly. The and or operators are the gatekeepers in SQL that determine whether a record's data fits the criteria you've set. The and operator is like an all-inclusive resort. Only records that meet all your specified conditions get to pass. For example, select from employees where department equals marketing and salary 50,000. We'll list only those in marketing earning above 50,000. The or operator is more welcoming, allowing records to show up if they meet any one of your conditions. So, select from employees where department equals marketing or department equals sales. We'll display employees from both departments, broadening your results. Question 20. Explain the having statement in SQL. Answer: the having clause in SQL comes into play when you're dealing with group data and you want to apply a filter based on an aggregate function like count, sum, or AVG. It's a bit like where's more analytical cousin. After you've grouped your data with the group by clause, having will let you apply a condition to each group. For instance, select department, count from employees group by department having count 10. Will only return departments where the number of employees exceeds 10. It's an essential tool for making sense of large datasets and deriving meaningful insights. Question 21. What is the difference between the having and where clauses in SQL? Answer: the key distinction lies in their application to datasets. The where clause filters rows before any grouping occurs, ideal for eliminating unwanted data from the outset. It operates without the ability to handle aggregate functions. Conversely, the having clause is specifically designed to filter groups after the group by clause has done its job. It's adept at using aggregate functions to filter group data, like having a count greater than a certain number. Question 22. What is the difference between the delete and truncate commands in SQL? Answer: when managing data in SQL, understanding the difference between delete and truncate commands is crucial for effective database manipulation. The delete command is classified as a data manipulation language, or DML command. It's used to selectively remove rows one at a time from a table, with each deletion logged in the transaction log. This process tends to be slower, particularly with large tables, due to the overhead of logging each row's deletion. However, it offers the flexibility to specify which rows to delete by using a where clause. Moreover, if you execute delete within a transaction, you have the option to roll back changes, providing a safety net for unintended data removal. Delete also respects the identity counter on the table, meaning it won't reset it after the operation. In contrast, the truncate command is a data definition language, or DDL command. It swiftly removes all rows from a table, not by logging individual row deletions, but by deallocating the data pages entirely. This method is significantly faster as it bypasses the transaction log for each row. However, it doesn't allow for partial deletions. There's no option to use a where clause, making it an all-or-nothing operation. Once executed, you cannot roll back a truncate command. An additional side effect of the truncate command is that it resets any identity counters in the table, effectively reinitializing the identity value for new rows. While delete acquires row-level locks during its operation, truncate typically locks at the table level. For example, executing delete from employees where department equals HR will remove employees only from the HR department. On the other hand, truncate table employees will eliminate all records from the employees table without discrimination. Choosing between delete and truncate depends on your specific needs, whether you need a fine-tuned deletion process with the ability to undo or a fast, complete table cleanup. Question 23. Can you explain what a DBMS is and the different types of DBMS? Answer: DBMS, or Database Management System, is the software that acts as the intermediary between users and databases. It manages the data, the database engine, and the schema to facilitate seamless data retrieval, manipulation, and administration. Ensuring data's consistency, security, and integrity is part of its core functions. There are several types of DBMS, each suited to different needs. Relational DBMS. RDBM is the most prevalent type. It uses a table-based structure with defined relationships via foreign keys, exemplified by MySQL and Oracle. Hierarchical DBMS is a tree-like data structure, perfect for hierarchical relationships, like eBeams IMS, network DBMS. This supports complex many-to-many relationships, allowing multiple linkages, as seen with IDs. Object-oriented DBMS stores data as objects, mirroring object-oriented programming used by systems like ObjectDB. Document-oriented DBMS or NoSQL, designed for flexible, document-oriented information management, with MongoDB being a well-known example. The choice of DBMS largely depends on the specific requirements of your data and the application at hand. Question 24. What are union, minus, and intersect commands in SQL? Answer. Each of these commands is a set operation used to handle the results of two select statements in a unique way. Union. This operation takes the results of two queries and combines them into a single result set. It automatically removes duplicate rows, ensuring that each value is unique. Imagine you have two lists of names, one from each query. Union would create a new list with every name from both, but no name would appear twice. Minus. The minus command comes into play when you want to find what's exclusive to the first select statement in comparison to the second. It filters out the rows from the first query that also appear in the second, leaving you with only the unique rows from the first. Intersect. This command is all about finding commonality. It returns only the rows that are found in both select statements, effectively pinpointing the overlap between them. Question 25. Can you explain the merge statement in SQL? Answer. The merge statement, often referred to as upsert, is SQL's way of streamlining the process of updating and inserting data. It lets you merge data from a source table or query into a target table. The beauty of merge is its ability to conditionally execute insert, update, or delete actions based on whether the data matches or not. For instance, if a record from the source table doesn't exist in the target, merge can insert it. If it does exist, merge can update the target with the new values, and if certain conditions are met, it can also delete rows. It's a powerful tool for keeping tables synchronized and managing data efficiently. Question 26. How do you use the with clause CTE in SQL, and what is CTE? Answer. The with clause in SQL is a powerful feature used to create common table expressions, or CTES. A CTE simplifies complex queries by breaking them down into simpler, more manageable parts. It effectively creates a temporary result set that is accessible within a select, insert, update, or delete statement. Here's an example of how it works. Suppose you have a table named Employees, and you want to focus on data related to the HR department. You could write, with Temptable as select from Employees, where department equals HR select from Temptable. This query first defines a temporary table, Temptable, that contains all records from the Employees table, where the department is HR. Then, the select statement retrieves all records from this temporary table. The CTE is useful because it allows you to structure your SQL query in a way that is easier to read and maintain, especially when dealing with complex data manipulation tasks. Question 27. What is the need for a merge statement in SQL? Answer. The merge statement, also known as an upsert, is an indispensable tool in SQL for efficiently synchronizing data across tables. Imagine you have a table that tracks inventory levels and a second one that logs incoming stock. Instead of writing separate insert, update, and delete statements for each item's change, the merge statement allows you to streamline these operations into one. This consolidation is not just a matter of convenience, it's about efficiency and accuracy. With merge, you can update existing records when the incoming stock data matches what's in inventory, insert new records when there's a new item, and even delete records if necessary, all with a single statement. It simplifies your code, making it more readable and easier to maintain. Furthermore, merge shines in data warehousing scenarios where tables must be regularly updated to reflect the latest data from different sources. It's all about keeping your data consistent, reliable, and up-to-date with as little complexity as possible. Question 28. Can you explain the concept of a database schema? Answer. A database schema is essentially the structural framework of a database, detailed in a language that the Database Management System, or DBMS, understands. Think of it as the architectural blueprint of a database. It outlines the organization of data, the way in which various tables are laid out, and the relationships among them. The schema encompasses table structures, the columns they contain, along with the data types and constraints of those columns, and the intricate web of connections between different tables. It's this schema that dictates the logical configuration of the entire database or a part of it. Question 29. What are the differences between drop and truncate? Answer. Drop and truncate are two SQL commands that deal with how data is removed, but they operate quite differently. Drop command. The drop command is the SQL equivalent of a clean slate. It completely removes a table or database, including its structure and any associated data, indexes, and constraints. Once a table has been dropped, it's gone for good, along with any space it occupied. It's irreversible and immediate, making it a fast operation. For example, executing drop table employees will entirely remove the employees table from the database. Truncate command. On the other hand, the truncate command is like an efficient cleanup crew. It empties all the rows from a table, but the table's structure, including its columns, constraints, and indexes, stays intact. It's irreversible in terms of data deletion, but the table is still there, ready to be used again. Truncate is quicker than delete due to not logging individual row deletions, but it's generally a bit slower than drop since it preserves the table structure. It also resets any identity counters in the table. So, truncate table employees would delete all data within the employees table, but the table structure remains unscathed. Let's delve into the realm of SQL set operators and understand how they facilitate the merging of result sets from multiple select statements. Question 30. Can you explain the different set operators in SQL? Answer. SQL set operators are the tools you need when you want to combine the results of two or more select statements. Here's a rundown of the primary set operators and what they do. Union. This operator takes the results of two select statements and unifies them into a single result set. It's like creating a master list that automatically weeds out any duplicates. Union all. It works like union, but with a twist. It includes all duplicates. It's the operator you use when every instance counts, even if it's a repeat. Intersect. Looking for commonalities. Intersect filters the results to only those rows that appear in both select statements' results. Minus or except. With minus, you can subtract one result set from another, keeping only the unique rows from the first that aren't found in the second. These set operators are fundamental in performing logical operations that shape your data just the way you need it. Voice over. Question 31. What are some ways to use dynamic SQL? Voice over. Answer. Dynamic SQL is a flexible approach that adapts to various runtime requirements. Here's how it can be used. Prepared statements. Think of these as templates. You create a SQL statement structure and later fill in the blanks with different parameters as needed. Stored procedures. These are like SQL scripts that can be programmed to construct and execute queries dynamically, changing their behavior based on provided inputs. Execute immediate. This is a feature in PLSQL that lets you run a freshly built SQL statement or even a block of PLSQL code on the fly. Cursors with variables. Cursors can be defined to navigate through a result set that's based on a SQL statement built with variable parts, ideal for repetitive tasks that need a touch of variation each time. Dynamic SQL is your go-to when static SQL queries fall short, offering the flexibility to handle varying conditions or query structures with ease. Navigating through SQL tables can sometimes require you to selectively retrieve records based on their position. Let's uncover how to extract alternate rows and understand the functionality of join operations in SQL. Question 32. How can you fetch alternate odd-even records from a SQL table? Answer. To isolate alternate rows, such as odd or even records from a SQL table, the row number function comes into play alongside a where clause. Here's how it works. For odd rows, the query would be select from select, row number over order by column name as rownum from table name, where rownum %2 equals 0. And for even rows, select from select, row number over order by column name as rownum from table name, where rownum %2 equals 0. These queries assign a unique row number to each record using the row number function. Then, by using the modulus operator with 2, we can filter out either the odd or even rows by checking if the row number divided by 2 leaves a remainder of 0 or not. Question 33. Explain what a join operation is in SQL and the different types of joins. Answer. A join operation in SQL is a powerful tool used to combine rows from 2 or more tables based on a related column they share. Understanding the types of joins is crucial for any SQL user. Inner join. This is the most common type of join. It returns rows when there is a match in the columns being joined in both tables. Left join or left outer join. This join retrieves all the rows from the left table, along with matched rows from the right table. For rows without a match, it returns null for the right table's columns. Right join or right outer join. It does the opposite of a left join, returning all rows from the right table and the matched rows from the left table, filling in with nulls where there's no match. Full join or full outer join. A combination of left and right join. This operation fetches all rows when there's a match in either table. Cross join. This creates a Cartesian product, joining every row from the first table with every row from the second table. Each type of join caters to specific needs based on how you want to correlate the data from the tables involved. Question 34. Can you define what a subquery is in SQL? Answer. A subquery is a query tucked within another SQL query, typically residing within the where or having clause. These inner queries help perform operations that might otherwise need more complicated joins or unions. They're extremely versatile, capable of returning a single value or a subset of records back to the main query, thus enabling a layered approach to data retrieval. In the realm of SQL, subqueries are a fundamental concept, allowing for more complex and dynamic database queries. Let's dive into the different types of subqueries and how they're utilized. Question 35. Describe the different types of subqueries in SQL. Answer. Subqueries in SQL come in various forms, each serving a unique purpose. Single row subqueries. These return a single row to the outer SQL statement. They are typically used with single-row comparison operators such as equals, and so on. For instance, you might use a single-row subquery to fetch a specific customer's latest order details. Multiple-row subqueries. These can return multiple rows and are used with operators like in, any, and all. They're handy when you need to compare a value against a set of values, such as finding products that have prices within a certain range of other products. Scalar subqueries. A scalar subquery is one that returns a single value. It's used in places where single values are required, like in a select list or a where clause. An example could be selecting the total number of orders along with the average order value from a sales table. Correlated subqueries. These are queries that return an entire table, which can be referenced in the from clause of the outer query. They are unique because the subquery is re-evaluated for each row processed by the outer query. This type of subquery can be used to fetch rows from a table where a column matches a column in the outer table. Table subqueries, or derived tables. These are subqueries that return an entire table and are placed in the from clause of the outer query. They are used to create temporary tables that the outer query can then use, much like creating a view on the fly for immediate use within your SQL statement. Understanding and leveraging these subqueries can significantly enhance your querying power, allowing for more precise and efficient data manipulation and retrieval. Question 36. What is the difference between a cross-join and a natural join in SQL? Answer. Cross-join and natural join are both types of joins with distinct purposes. Cross-join. This is the join you use when you want to combine every row from two tables, resulting in a Cartesian product. It connects each row of the first table with every row of the second without needing a condition or even a common column. Natural join. This operation is more discerning. It automatically links tables based on columns of the same name and compatible types, effectively performing an inner join without explicitly stating the join condition. If there are no common column names, it acts like a cross-join. In essence, a cross-join connects rows indiscriminately, while a natural join looks for commonality in column names to determine the match. Question 37. Can you explain what an index is in SQL and why it's important? Answer. An index in SQL is akin to an index in a book. It's a mechanism that allows the database to find and access data quickly. It's typically built on columns used often in where clauses, join conditions, or for ordering data. The real value of indexes lies in their ability to boost query performance, ensuring that the database can retrieve information swiftly without scanning the entire table, which is especially critical for large databases. Question 38. What is the difference between a clustered and a non-clustered index in SQL? Answer. Understanding indexes is crucial for optimizing database performance. Let's break down the differences between clustered and non-clustered indexes. Clustered index. A clustered index sorts and physically stores the rows of a database table in sequence according to the index key. It's like a telephone directory, where entries are stored in order based on names. There can only be one clustered index per table, because the data can only be sorted in one way. This index type is generally faster for reading data, as it aligns with the physical storage sequence of rows. It doesn't require extra disk space, but modifications like insertions or deletions can be slower since the physical order must be maintained. It's particularly ideal for range-based queries and is often used as the default for the primary key in many databases. Non-clustered index. In contrast, a non-clustered index creates a separate structure from the data rows, which includes pointers to the actual data, akin to an index at the back of a textbook that refers you to the right pages. A table can have multiple non-clustered indexes, allowing for more flexibility. While it's slightly slower compared to a clustered index due to the additional lookup step, it's less impactful on data modifications. It requires additional disk space for storing the index entries separately from the actual data. Non-clustered indexes are suited for queries that target specific values and are commonly used for columns frequently involved in search conditions, but not primarily in range-based queries. In summary, clustered indexes are about order and swift data access, while non-clustered indexes offer flexibility and targeted data retrieval. Question 39. What is the drawback of using an index in a database? Answer. Indexes are a powerful feature in databases that can significantly improve the speed of data retrieval operations. However, they come with certain drawbacks that should be considered. Performance impact on write operations. While indexes can accelerate read queries like select statements, they can slow down write operations such as insert, update, and delete. This is because the database must update all relevant indexes whenever data is added, modified, or removed, which can be a costly operation in terms of performance, especially with large volumes of data or with many indexes. Increased storage requirements. Indexes consume additional storage space. Each index you create effectively duplicates some of the data from the original table and stores it in a way that makes searches faster. As a result, more disk space is required, which can be significant depending on the size of the database and the number of indexes. Maintenance overhead. Indexes require maintenance to keep them performing well. Over time, as data is added and removed, indexes can become fragmented. This fragmentation can degrade the performance benefits that indexes are supposed to provide. Regular index maintenance tasks, such as rebuilding or reorganizing indexes, are necessary to maintain optimal performance, which can be resource-intensive. Complexity and management. Having many indexes can make the database system more complex to manage. Deciding which indexes to create, balancing the write performance with read performance, and maintaining the indexes can add complexity to database administration. Query optimization overhead. The database query optimizer must choose the most efficient index to use for each query. If there are many indexes, the optimizer has more work to do, and sometimes it might not choose the most efficient path, leading to suboptimal query performance. In summary, while indexes are critical for improving query performance, their use needs to be balanced against the additional resource requirements and the potential performance hit on write operations. Careful planning and periodic review of the indexing strategy are essential to ensure that the benefits outweigh the drawbacks. Question 40. Can you list the different types of indexes in SQL? Answer. Apart from the commonly known clustered and non-clustered indexes, SQL supports a variety of index types, each tailored for specific use cases. Unique index. This index ensures that all values in a column or a set of columns are unique. It's crucial for maintaining data integrity where duplicates are not allowed. Composite index. Created on more than one column, composite indexes are ideal for queries that involve multiple columns and their conditions. Covering index. A type of index that includes all the columns a query needs. It can improve query performance as the database can find all the required data within the index itself. Bitmap index. Particularly efficient for columns with a limited number of distinct values, such as gender or marital status. It uses bitmaps and is fast for read operations. The selection of an index type is dependent on the specific data access and query patterns your database handles. Question 41. What is normalization in the context of databases? Answer. Normalization is a systematic approach to organizing data in a database. This process involves dividing a database into tables and defining relationships between them to minimize redundancy and dependency. The goal is to reduce and eliminate data anomalies, streamline database structure, and ensure data integrity. Normalization typically follows a series of steps known as normal forms, each addressing a particular type of issue within the database. Question 42. Can you explain denormalization in SQL? Question 43. What are the different types of normalization in databases? Answer. Normalization in databases is categorized into several normal forms. First, normal form 1NF ensures individual values in columns and uniqueness in rows. Second, normal form 2NF builds upon 1NF by removing partial dependencies on a primary key. Third, normal form 3NF eliminates transitive dependencies, further ensuring that non-key columns are dependent only on the primary key. Voice code normal form BCNF, a more rigorous version of 3NF, dealing with certain types of anomaly that 3NF does not handle. Advanced forms like the fourth normal form 4NF and fifth normal form 5NF address multi-valued dependencies and join dependencies, but these are less frequently implemented in practical database design. Question 44. Explain what are database mirroring and replication. Answer. In the quest for data redundancy and high availability, two critical techniques stand out in the world of databases: mirroring and replication. Database mirroring. This is a strategy for increasing data availability. It involves maintaining an exact copy of a database on a secondary server. All operations executed on the primary database are simultaneously mirrored to the secondary server. Should the primary server ever fail, the secondary server is poised to take over immediately, ensuring minimal downtime. This method is particularly favored for disaster recovery and achieving high availability of data, database replication. On the other hand, replication refers to the process of copying and distributing data and database objects from one database to another. It's a cornerstone for load balancing, providing data redundancy, and ensuring data consistency across multiple locations. Replication can be synchronous or asynchronous and is configurable at various granularities, from entire databases to specific tables or even views. It's a robust way to spread data across different servers or geographic locations, supporting complex distributed database systems. Both mirroring and replication are vital for modern databases, each serving its purpose to safeguard data and optimize database performance and reliability. Question 45. What is database sharding? Answer. Database sharding is an advanced data management technique used to handle very large databases. It involves splitting a large database into smaller, more manageable pieces known as shards, with each shard residing on a separate database server or instance. This division is more than just organizational. It allows each shard to operate independently, which can significantly distribute the load across servers. By doing so, sharding enhances the performance and scalability of large-scale database applications, particularly those dealing with massive datasets and high transaction volumes. Imagine a library so vast it doesn't fit into a single building. If you divide the library's collection across multiple buildings, with each housing different categories of books, finding a specific book can become much easier and quicker. That's the essence of database sharding. It's about optimizing resource utilization and achieving high performance in environments where the data and workload are enormous. Question 46. How would you approach performance tuning a slow-running query in a very large database? To approach performance tuning a slow-running query in a very large database, I would take the following steps. Analyze the execution plan. Pinpoint bottlenecks like full table scans or inefficient joins. Optimize indexes. Add or modify indexes for key columns. Perform index maintenance. Refactor the query. Simplify complex queries and convert subqueries to joins when advantageous. Table partitioning. Implement partitioning to improve data management and query performance. Adjust configuration. Tune database settings to optimize resource use. Implement caching. Use application level and database caching to reduce load. Monitor performance. Employ tools to continually monitor and address new inefficiencies. Effective tuning involves a balance between query design, indexing strategy, and system resources. Question 47. Can you explain the concept of table partitioning? Answer. Table partitioning is like organizing a vast collection of records into more accessible sections. In SQL, it's a technique where a large table is divided into several smaller, more manageable segments, known as partitions. Each partition can reside on its own file or file group within the database. This makes it simpler to perform operations such as queries, backups, and maintenance tasks, as they can be executed on individual partitions. It's an approach that significantly boosts performance and manageability, especially in massive tables that would otherwise be cumbersome to handle. Question 48. How do you manage large-scale databases? Answer. Managing large-scale databases is a multifaceted challenge that requires a combination of strategies. Sharding. This involves distributing the data across multiple servers, making it easier to manage vast datasets. Partitioning. As mentioned earlier, partitioning divides tables into parts for more efficient data management. Indexing. Implementing proper indexing enhances query performance, but it's crucial to avoid over-indexing, which can hinder write operations. Replication and mirroring. These techniques ensure data redundancy and high availability. Monitoring and maintenance. Regular monitoring and performance tuning, along with consistent backups, help maintain database health and prevent data loss. Incorporating these strategies effectively is the key to managing large databases. Question 49. How do you manage large-scale databases for optimal performance? Answer. Achieving optimal performance in large-scale databases requires a focused approach. Efficient indexing. It's about finding the right balance in indexing to speed up queries without affecting write operations negatively. Database sharding and partitioning. These techniques distribute the workload and data, facilitating better performance. Resource management. Ensuring that the database has the necessary hardware resources and that these resources are optimized. Query optimization. Writing and fine-tuning SQL queries to ensure they run efficiently. Regular maintenance. Performing routine updates and cleanups to keep the database running smoothly. Monitoring and scaling. Keeping a close watch on performance metrics and being ready to scale resources as needed. Managing large-scale databases is a dynamic process that involves careful planning and ongoing adjustments to meet the demands of the data and the users. In a bustling world where data is accessed by many users simultaneously, SQL databases employ smart strategies to manage concurrency. Let's dive into how they maintain order amid potential chaos. Question 50. How do SQL databases handle concurrency? Answer. SQL databases approach concurrency control with a two-pronged strategy: locking mechanisms and transaction isolation levels. First, locking mechanisms are the database's bouncers, so to speak. They prevent multiple transactions from interfering with each other by locking the data being modified. These locks ensure that when one transaction is updating a piece of data, no other transaction can alter that same data until the first transaction is complete, safeguarding the integrity of the data. The second prong, transaction isolation levels, are like different privacy settings for transactions. They define the degree to which the operations of one transaction are isolated from those of another. These levels handle potential problems like dirty reads, where one transaction sees uncommitted changes from another; non-repeatable reads, where a row's data changes between reads within the same transaction; phantom reads, where a transaction notices new rows added by other transactions. The SQL standard defines several isolation levels, each with its own rules for visibility of data changes. Read uncommitted, the most lenient level, where transactions can see uncommitted changes from others, potentially leading to dirty reads. Read committed ensures that a transaction only reads data that has been committed, thus avoiding dirty reads. Repeatable read prevents non-repeatable reads by ensuring that if a transaction reads a row, it can read that same row again and get the same values. Serializable, the strictest level, which essentially queues transactions to prevent phantom reads, making each transaction appear as if it were the only one interacting with the database. By carefully choosing the appropriate locking mechanisms and isolation levels, SQL databases can balance the need for concurrent access with a need to prevent data anomalies, ensuring reliable and consistent performance. Question 51. What are the best practices for SQL database maintenance? Answer. Keeping an SQL database at peak performance involves a series of critical maintenance practices. Regular backups. This is your safety net against data loss. Frequent backups ensure that you can restore your database to a point in time should anything go wrong. Monitoring. Keep a vigilant eye on your database's performance and resource utilization. Active monitoring helps in quickly identifying and addressing any arising issues. Index maintenance. Indexes speed up query performance, but they can become fragmented over time. Regularly rebuilding or reorganizing indexes can maintain or even enhance query efficiency. Updating statistics. SQL Server Query Optimizer relies on statistics to choose the best execution plans. Keeping these statistics current is essential for optimal query performance. Consistency checks. Regularly scheduled consistency checks can detect and rectify data corruption, ensuring the integrity of your data. Purge and archive. Over time, databases accumulate data that may no longer be frequently accessed. Purging obsolete data and archiving old data helps in managing storage and improves performance. Implementing these practices will not only extend the life of your database, but also improve its efficiency and responsiveness, making it a reliable resource for your applications. Question 52. What is a data warehouse? Answer. In the digital age, where data is the new gold, a data warehouse serves as the central vault. A data warehouse is a centralized repository designed to store and manage large volumes of data from multiple sources. Unlike a regular database that's typically used for transaction processing, a data warehouse is built for query and analysis. It provides a consolidated view of corporate data, making it an invaluable resource for business intelligence. It's not just about storage. A data warehouse is optimized for the loading, storing, and retrieval of vast amounts of data, catering specifically to analytical purposes. By allowing data to be aggregated and analyzed, a data warehouse becomes a critical tool for supporting decision-making processes within a business. It enables organizations to mine their data for insights, trends, and strategic direction, all while supporting large-scale, complex queries and reports. So, when you think of a data warehouse, imagine a supercharged storage unit brimming with data that's not only secure, but also primed for generating business intelligence that can pivot the direction of a company. Question 53. Can you explain what SQL injection is and how it can be prevented? Answer. SQL injection is a critical security flaw that allows attackers to manipulate the database by inserting malicious SQL code into an otherwise benign query. To shield against this, developers should employ prepared statements with parameterized queries, which separate SQL logic from data input. Validating and sanitizing user inputs, utilizing stored procedures, and restricting database permissions are also vital steps. And of course, regularly updating your database software and applications is crucial to protect against known vulnerabilities. Question 54. How do you implement error handling in SQL? Answer. Error handling in SQL is effectively managed using try-catch blocks. The try block contains the code that may trigger an error, while the catch block is designed to respond to any errors that arise. If an error occurs, the catch block will execute, allowing you to handle the situation by logging the error, rolling back a transaction, or executing alternative SQL code. Question 55. How can SQL handle null values? Answer. SQL provides specific functions like isNull and coalesce to deal with null values, which represent unknown or missing data. These functions allow for a default value to be returned in place of null. Remember, null is not equivalent to 0 or an empty string, and special operators like isNull and isNotNull are needed for comparisons instead of the standard equality operators. Question 56. Can you differentiate between a null value 0 and a blank space in SQL? Answer. Absolutely. In SQL, a null value signifies the absence of data, whereas 0 is an actual numeric value, and a blank space is a character value. These are not interchangeable. Null values require careful handling since they represent the lack of a value and can't be compared using standard operators. Question 57. What are aggregate functions in SQL? Can you give some examples? Answer. Aggregate functions are powerful SQL tools that perform calculations on a dataset and return a single value from the set. Some common examples include sum, which totals up numeric values, AVG for calculating the average, count for tallying the number of rows, and max and min for finding the highest and lowest values, respectively. These functions are often used in conjunction with the group by clause to aggregate data across distinct groups. Question 58. Can you explain the difference between aggregate and scalar functions in SQL? Answer. In SQL, functions can be categorized based on their operation on data. Aggregate functions, such as sum, AVG, and count, perform calculations across multiple rows to yield a single result per group. These are instrumental in deriving insights from grouped data. Scalar functions, however, are applied to individual values. For each row processed, a scalar function like upper, which capitalizes text, or round, which adjusts numeric values to a specified precision, returns a single value. The key distinction lies in the scope. aggregate for multiple rows and scalar for single values. Question 59. What are the key considerations for database security? Answer. Database security is multifaceted. It starts with robust authentication to ensure only authorized users gain access. Proper access controls must be in place, dictating who can see or do what within the database. Sensitive data require encryption to protect against breaches. Regular updates and security patches are non-negotiable for defending against vulnerabilities. Monitoring and auditing provide oversight on database activities, and a solid backup and recovery strategy ensures resilience against data loss or corruption. Question 60. How is database security managed? Answer. Managing database security is a dynamic and ongoing process. It involves setting up strong user authentication protocols, enforcing access controls, and ensuring that data is encrypted both at rest and in transit to safeguard it from unauthorized access. Conducting regular security audits, vigilant monitoring, and applying security updates promptly are also key to maintaining database security. Moreover, part of security management is about user education, ensuring that everyone understands and adheres to best practices to maintain the integrity and confidentiality of the data. Question 61. Can you explain what a stored procedure is in SQL? Answer. A stored procedure is a powerful feature in SQL, which allows you to save a set of SQL statements under a name and execute them as a mini-program. This can be thought of as a function in programming languages. Stored procedures can take in parameters, perform operations including complex logic, and return results. They're excellent for repetitive tasks, boosting performance, and preventing SQL injection threats. They also help minimize network traffic and encapsulate business logic within the database layer, fostering maintainability and security. Question 62. Can you define what a view is in SQL? Answer. A view is essentially a virtual table in SQL that is constructed from a query using one or more real tables. While it behaves like a table containing rows and columns, it doesn't store data itself. Think of it as a saved query that you can reference like a table, perfect for simplifying complex queries and presenting data in a specific format without duplicating data. Question 63. What are views used for in SQL? Answer. Views serve a variety of purposes in SQL. They can simplify the structure of complex queries, enhance data security by limiting user access to certain rows or columns, and provide a customized perspective of the data. Views also encapsulate the SQL query logic, making it more accessible for users to retrieve and manipulate data, while offering an abstraction layer that streamlines data handling and analysis. Question 64. What are user-defined functions? Answer. User-defined functions, or UDIFs, are custom functions that you can create in SQL to perform operations not available in the built-in functions. They encapsulate logic that can be reused in various places, such as in queries or stored procedures. UDIFs can return individual values, like scalar functions or tables, enhancing the modularity and reusability of your SQL code. Question 65. What are the different types of user-defined functions in SQL? Answer. There are mainly two types of user-defined functions in SQL. Scalar functions. These return a single value based on the input value. Table-valued functions. These return a table data type. Table-valued functions can be further classified into inline table-valued functions and multi-statement table-valued functions. The former is like a single select query, while the latter can have multiple statements and a more complex structure. Question 66. Can you explain the difference between a view and a table in SQL? Certainly. In SQL, a view is like a virtual table based on a query. It doesn't physically store data, but presents it in a specified format. A table, on the other hand, physically stores the data. Views are used to simplify queries and present data, whereas tables store the raw, structured data. Performance-wise, views might be slower since they fetch data from underlying tables, but tables are faster as they directly access the data. Question 67. What is the difference between a function and a stored procedure in SQL? Functions must return a value and are typically used for data computations. They can return either a single value or a table. Stored procedures might not return a value and are used for a variety of actions like modifying database structures and processing data. Functions usually have just input parameters and can't change the database state, while stored procedures can have input-output parameters and can indeed change the state. Question 68. Can you explain what a trigger is in SQL? A trigger in SQL is a special type of stored procedure that automatically runs when certain events occur in the database. Triggers are commonly used for enforcing business rules, maintaining audit logs, and synchronizing data. There are different types of triggers based on the kind of database operation that activates them, such as insert, update, or delete. Triggers can be defined to execute before or after the triggering event. For example, a trigger can be set to check business constraints before updating a record or to automatically update a related table after a record is inserted. Question 69. What are window functions in SQL? Window functions are like the binoculars of SQL, allowing you to peer across a landscape of rows and perform calculations over these related rows. The magic of window functions is that they don't lump your results into one single output. Instead, they keep each row's identity intact, while still doing the heavy lifting of calculations like running totals, rankings, moving averages, and more. Think of row number, which assigns a unique sequential integer to rows within a result set, or rank, which does something similar, but can assign the same rank to tie values. Dense rank is close cousin, except it doesn't skip numbers in the sequence. Then we have navigational functions like lead and lag, letting you peek at rows ahead or behind without moving from your current spot. And when we get to sum over and AVG over, we're talking about taking those aggregate functions you know and love and supercharging them to work over specified windows of data. All of these are orchestrated by the over clause, which is like the conductor telling each function which rows to consider as part of its performance. Question 70. Explain the concept of data integrity. Data integrity is the cornerstone of database trustworthiness. It's all about ensuring that the data you store remains accurate, consistent, and reliable throughout its life. Imagine a librarian meticulously organizing books and ensuring each one is in its right place, unharmed and unchanged. In the database world, we achieve this through various constraints. Primary keys and foreign keys establish relationships and uniqueness, while check constraints and data validation rules ensure that only appropriate data makes its way into the database. When data integrity is upheld, you can trust that the information in your database is precisely what it should be, no more, no less. Question 71. What are the ACID properties in database? Answer. The ACID properties are the bedrock of transactional database systems. Let's unpack the acronym. Atomicity is the all-or-nothing principle. Think of a transaction as a series of steps, either every step completes or none do, like a space shuttle launch sequence. Consistency is the assurance that every transaction transitions the database from one valid state to another. It's like a safety check, ensuring all rules are followed before a plane takes off. Isolation means each transaction occurs in solitude, even if multiple transactions happen simultaneously. Imagine an exam setting where each student is shielded from others to ensure their work is their own. Durability guarantees that once a transaction is committed, it's set in stone, even if the power goes out or the system crashes, like sending a letter through certified mail. Together, these principles ensure that database transactions are executed safely and reliably, giving users confidence in their data's stability and endurance. Question 72. Explain the concept of transactions in SQL. Answer. Transactions in SQL are a sequence of operations performed as a single logical unit of work. A transaction has a beginning and an end, and it must be entirely completed to ensure database integrity. If a transaction is successful, all data modifications made during the transaction are committed and become a permanent part of the database. If a transaction encounters an error, all the changes are rolled back to the previous state of the database. Transactions ensure data integrity and consistency in the event of an error or system failure. Question 73. How do you handle transactions in distributed databases? Answer. Handling transactions in distributed databases is indeed a complex affair, akin to conducting an orchestra spread across different cities. The goal is to maintain the ACID properties, despite the challenges of network latency and system diversity. The two-phase commit protocol is like a symphony conductor, ensuring each musician the participating databases plays their part correctly. Either everyone strikes the right chord, committing to the transaction, or everyone stops, rolling back any changes. This coordinated dance is crucial for consistency, but requires a thoughtful architecture that harmoniously balances reliability with performance. Question 74. Can you explain the basics of T-SQL? T-SQL, or Transact SQL, is an extension of SQL used in Microsoft SQL Server. It adds additional features to standard SQL, such as transaction control, exception and error handling, and row processing. T-SQL includes additional syntax for declaring variables, conditional processing, and procedural logic. It is used for writing queries, as well as for creating and managing database objects like tables, views, stored procedures, and triggers. Question 75. What are group functions in SQL? Answer. Group functions, or aggregate functions, are the calculators of the SQL world. They work on a set of rows to give you a singular value that sums up the entire group. Imagine you're at a farmer's market looking at baskets of apples. Functions like sum tell you the total weight. AVG gives you the average weight per basket. Count tells you how many baskets there are. And max and min reveal the heaviest and lightest baskets, respectively. When paired with the group by clause, these functions help organize data into meaningful summaries, making your data analysis sharp and efficient. Question 75. What is a relationship in SQL, and what are the types of relationships? Answer. In the relational database landscape, relationship is the bond between tables. It's like the family ties in a genealogy chart. A one-to-one relationship is an exclusive pair. Think of it as a married couple. One-to-many or many-to-one relationships are like a parent to children. One parent, multiple children. Many-to-many relationships are like social networks. Many friends, connecting to many others, often through a mutual friend, which in database terms is a junction table. These relationships are established using primary and foreign keys, creating a web of data connections that bolster the database's integrity and navigability. Question 76. How do you insert null values into a column when inserting data in SQL? Sometimes we have missing information when we're inputting data into our databases. How does SQL handle this? Inserting null values into SQL is straightforward. Null represents the absence of a value or simply unknown. It's different from a zero or a blank space, which are actual values. To insert a null value, you simply use the word null in your insert statement. For example, let's say we're adding a new employee named John Doe to our employees table, but we don't know his department yet. Our statement would look like this. Insert into employee's name, department, salary values John Doe, null, 50,000. In this case, the department field for John Doe is left intentionally blank with null, indicating that we're yet to obtain that piece of information. Remember, the column must be set to accept null values. Otherwise, our database will raise an error, refusing to insert a void where it expects something concrete. Question 77. Explain the difference between local and global variables. In the context of programming, including SQL, the primary difference between local and global variables lies in their scope and accessibility. Local variable. These are declared within a function, stored procedure, or block, and can only be accessed and used within that specific scope. Once the function or procedure ends, or control leaves the block, these variables cease to exist. They are used for temporary storage of information and to maintain data that is private to that function or block. Global variable. Global variables are declared outside any function, procedure, or block, making them accessible from any part of the program. They retain their value throughout the life of the program and can be accessed and modified by any part of the code. In SQL, global variables are often represented by system-defined variables like at version in SQL Server, or by defining parameters that are accessible throughout the session. Question 78. What is the difference between common table expressions CTES and temporary tables in T? Answer. CTES and temporary tables serve different purposes in T-SQL. A CTE is a temporary result set valid only during the execution of a single select, insert, update, delete, or merge statement. CTES are used for recursive queries, simplifying complex joins and subqueries. They are non-persistent and disappear once the query completes. On the other hand, temporary tables are created in the TempDB database and persist for the duration of the user session, or the procedure that created them. They are ideal for storing and manipulating intermediate results for complex calculations. CTES are preferred for readability and maintainability, while temporary tables are used for large datasets requiring multiple references in different queries. Question 79. What is table partitioning in T-SQL, and what are its benefits? Answer. Table partitioning in T-SQL involves dividing a database table into multiple, smaller, and more manageable pieces or partitions, but treating them as a single table. This is particularly beneficial for large tables and improves query performance, maintenance operations, and data management. It allows faster data access and loading, as operations can target only relevant partitions. For instance, a table with sales data can be partitioned by year, allowing quick access to a specific year's data without scanning the entire table. Question 80. Can you explain what dynamic SQL is and provide an example of its use in T-SQL? Dynamic SQL in T-SQL refers to SQL commands that are constructed as strings and executed at runtime. It's useful when you need to write flexible queries based on changing conditions. However, it requires careful implementation to prevent SQL injection attacks. An example of dynamic SQL is using the execute SQL stored procedure. Here's a simple example. Let's say we have a variable table name and we want to fetch its data. We'd declare a variable for our table, build our SQL command as a string, and execute it using execute SQL like so. And there you have it. Dynamic SQL allows for flexible and responsive query construction, giving you the power to handle variable database inputs safely and efficiently. For more dynamic discussions on all things SQL, don't forget to like, subscribe, and turn on notifications. If you've got SQL questions, drop them in the comments, and we might feature them in future episodes. Keep those queries versatile, and as always, code responsibly. And that's a wrap on our enlightening journey through the world of programming. A huge thanks to everyone who joined us for this series. We hope you've gleaned valuable insights and skills to elevate your coding prowess. If you have any questions or need further information, don't hesitate to reach out to us at info@helloworldacademy, UK. We're here to assist you on your coding adventure. Before we sign off, remember to subscribe to our channel for more tutorials, deep dives, and expert tips that will guide you to code like a pro. Check out our extensive course offerings, from database development to web and game development, and even a comprehensive programming course, all available at your fingertips. Don't forget to visit our official website, www.helloworldacademy.UK, to discover more learning materials, courses, and resources curated just for you. Thank you for watching, and we can't wait to see what you'll create with the skills you've acquired. Keep coding, keep creating, and until next time, keep soaring high with the Hello World Academy.